Hello everyone, this is Alan Weisberger talking to you from the Open Network Summit, the big annual event for everything related to open networking, software-defined networking, and more recently, network function virtualization. And with me is my colleague who I've known for 31 years, Dan Pitt. Dan has had a very eclectic career leading the IBM Token Ring delegation and IEEE 802.5 Standards Committee, working at HP Labs, at Bay Networks, Dean of Engineering at Santa Clara University, as a consultant helping startups get going, and for the last 4 years, the executive director of the Open Network Foundation. Now, traditionally, a forum or a foundation is a private organization that works on reference architectures, specifications, market awareness, and sometimes certification testing and interoperability testing. How does ONF align with those objectives, and what new things are you taking on, new and different, that the traditional forums don't do?
So it's good to be with you, Alan. ONF has done all of those things, but none of them is an end in itself. They're all means to an end. Our end is the successful commercial adoption of open software-defined networking. So we do standardization, we do specification, we do market awareness, we do interoperability testing, and now we are also producing open source software. And that's the biggest change. The reason we do that is that for operators, whether they're telcos or enterprises or data center operators, to get their hands around this technology and understand it and what it can do for them, we have to produce more than just documents. So we are on this journey from PDF to Python, we say, where we generate architecture specifications and guidelines, but we also produce open source software, and we work in close harmony with the major open source software organizations and projects.
Yesterday, during your abbreviated 2-minute keynote, you mentioned, I thought, something that was very significant towards that end, the Atrium project, which I've had the pleasure of hearing about during the demo tour. Can you tell us a little bit about the Atrium project and what problem it solves, and where is it going to go forward from here?
Sure. Atrium solves two really big problems. One is for those organizations that want to deploy and learn about software-defined networking using open source solutions and platforms. There's no way they can do that now without going to a number of different sites, downloading some project, trying to do their own system integration. It's like trying to build your own PC from a bunch of components. So we've integrated those into a vertical stack. It's just a narrow slice that has an application, has a control plane, and it has a forwarding plane. The other thing we're doing is looking at the specifics of what those things are. The application right now is Quagga BGP peering, all open source. The control plane is ONOS, the Open Network Operating System. That's open source, and it runs Quagga. And the control plane talks to the forwarding plane using OpenFlow 1.3. And the forwarding plane, we have 7 OpenFlow switches, 2 of which are white box switches built by us using the Open Compute Project architecture, and the other 5 are 5 different vendor OpenFlow switches with different chips, different pipelines, and different architectures. They are all interoperable, so we have interoperable OpenFlow 1.3 now in hardware for the first time.
This is a major, major accomplishment because of various intricacies involved in switch silicon. Interoperability has been very, very difficult to achieve, but on the exhibit floor, you've actually demonstrated that with several vendors running the ONOS software for the control plane and generic compute server, interfacing using OpenFlow version 1.3 as the southbound API to the packet forwarding engine.
That's correct, and you can see all 7 switches, 2 of which are ours, and 5 of which were done by the vendors. And the way this was achieved is by requiring the different vendors that wanted to be part of this to write their own driver into ONOS. But then more importantly, we worked with the ONOS developers hand in hand to develop something called a Flow Objectives interface that makes the application, in this case Quagga, independent of the chips. And this flow objectives interface translates really an abstract flow expresses it as an objective in an abstract way rather than as a specific driver for each chip. Therefore, we're demonstrating not only open flow switch interoperability, but also application portability.
That's terrific, Dan. A number of panelists and speakers at this conference talked about using OpenFlow in strange ways, non-traditional ways. Can you comment on some of those ways, Dan, in addition to being the southbound API from the control plane to the data plane?
Can you give me a reference of what's more specific you're inquiring about there?
Both Google and AT&T announced today that they were using OpenFlow, but not in the way that we think of. They didn't actually define how. Do you have any perspective on how that might be used?
So this is the first time Google has disclosed that they're using OpenFlow inside their data center. They announced 3 years ago they're doing it between their data centers. This time they're doing it in their data center. They've built their own switches. We knew that, like they build their own servers. They have their own centralized control plane, which they wrote. It's not BGP, it's not OSPF, it's not ISIS. It's their own, but it meets what they need for the kind of traffic characteristics they have in their data center, which are different from most other people's. In the case of AT&T, they are transforming their network to a software-driven network with a logically centralized control over a flexible infrastructure. They're just starting to roll it out in access aggregation and the core on the both fixed and wireless sides. And they announced that they just said in conversation that they are using OpenFlow to do this as well.
Okay, thank you, Dan. There are two other interfaces that I think ONF has on the roadmap, but not much progress. Maybe you can give us the status of it. One is the Northbound interface, and many people think that some subset of Cloud Stack is the solution there. And then there's the EastWest interface, which would connect so-called centralized controllers from different network domains, almost like an NNI.
So on the Northbound interface, we have actually been working to define what that would represent, to abstract what the network can provide to the applications and what that applications need from the network. And rather than standardizing Northbound interface in a committee, what we've done is define a couple of examples and we're putting them in code. One is a media service interface for the enterprise industry that involves, as something we can see in our open source SDN.org website portal, a vehicle for doing quality of service for voice over IP. So that has those characteristics across an abstract interface. The other is an intent-based framework that we defined initially and we proposed as a project in the OpenDaylight project. They accepted it. That's being put into code, but we are also working to make it independent of the control plane so that we are developing an intent-based engine, the application, and different runtimes for ONOS and OpenDaylight. And so our job in Northbound interfaces is understanding what the abstraction should be for different purposes, and in a carrier's world, they have different levels of abstraction for themselves and then for their customers, and then translating those into parameters that can be coded up as a library of Northbound interface components.
Just as a clarification for the viewers, ONOS and OpenDaylight are two consortiums that are producing open source code for SDN. Can you say a little bit more about it and maybe position each one where one might be better suited for carrier networks, the other might be better suited for enterprise networks or smart cities?
So we are officially controller neutral, and we're just excited to see so many people putting effort into open source SDN control planes, which is what each of these is. And there are different approaches, there are different structure of the organizations, but there's a lot of investment going into both of them. And so it was Huawei this morning said we're investing in both. We're kind of looking at ONOS more for communication service providers environments, and we're looking at OpenDaylight for enterprise, smart cities, and Internet of Things applications. It's still very early days, Alan, and we have to see deployments of these. We want to see them tested, see what the performance characteristics turn out to be, and then the community will decide.
Okay, back to the second part of the previous question on the East-West interface, something you and I discussed about a year ago. Big complaint about centralized control is it doesn't scale to a big network. So you need centralized controllers for various domains, and the way you connect them is through something called an East-West interface. Is that still BGP, or is it going to be something else?
It's too soon to say. We do have an effort going on in the East-West interface. And you know, Alan, it's pretty easy for me to tell the northbound from the southbound, but I have a hard time telling the eastbound from the westbound.
Okay. Let me go on to the management interface. There is, in fact, a distinct management plane, whether some large vendor says there isn't or not. The functions of provisioning, configuration, reconfiguration, including speed changes, is a management plane function. What, if anything, is ONF doing about incorporating a management plane into SDN?
So we have not yet taken the work on management planes very far. We have a configuration and management project working group that's mostly worked on configuration, done a little bit of work on OA&M with an event framework that we published, and you can go on our website and find that. And what we're trying to do now is we're talking to the major operators and trying to understand what is their sort of set of requirements for integrating SDN management with their existing management products and infrastructure. They're facing a challenge of migrating to SDN without disrupting what they already do. And rather than our defining something completely new, we want to see how can we help them migrate the management side of SDN with things that already work for them. Thanks.
Let's talk about some of the other projects ongoing in ONF. About 3 years ago, I was talking with Lyndon of Siena about the Optical Transport network interface. That seemed to take on more importance today when AT&T talked about disaggregating the network elements and trying to move as much software functions as possible into open software interfaces. What's the status of not only the optical transport, but any other low-level function that might be disaggregated?
So it's been a big year, actually, for optical transport in SDN. And what we have done is we partnered with the Optical Internetworking Forum, and we, together with 7 major operators and 9 other organizations, did a proof of concept demo of packet optical integration using the OpenFlow optical extensions. This allows you to manage layers 0, 1, and 2 in a consistent manner, and you will actually see products around on this demo floor that now work at a software level only to try to optimize and the configuration of traffic across both packet links and optical links, because they can now do this. We issued a specification for optical extensions to OpenFlow. We continue to work on that. We are now also working very hard on wireless. We have already demonstrated unified management of fixed and wireless networks in the enterprise. We're working on virtual EPC and on wireless backhaul as well.
Terrific. When ONF got started, there really was only one version of SDN, which I refer to as the pure version of SDN. Strict separation of data and control plane, centralized controller, and OpenFlow as the southbound API. Now there are many, many different versions. 2 questions here. Number 1, is Open Network Foundation going to incorporate any of these versions? And question 2 is, what do you think about the entire market being fragmented because there's so much confusion regarding these different SDN versions, claims, and reference architectures?
All right, so I have kind of 2 takes on that, Alan. One is that this is a period of disruption, of experimentation, of trials, and there will be lots of different solutions proposed. And we are seeing that. And especially as the vendors and their customers deal with a lot of brownfield environments, how do I get there from here? How can I get some benefit of SDN without going to pure SDN right away? And so we're happy to see that happen. However, we also are driving the industry toward open SDN, where the fact that you are trying to get that from here doesn't mean you can lead your customer into another lock-in situation calling it SDN. We're in favor of open interfaces defined by the community, not defined by and controlled by a single party. And by keeping everybody moving forward, we're helping to drive the industry toward where they can adopt pure SDN as soon as they wish to. And I think that's a practical decision that we've had to make to help the industry get there from here. And so far it seems to be paying dividends.
Great. Well, I'd like to thank you very much, Dan, for this interview. Just a couple of quick softball questions. Number one, do you still have a 617 area code on your cell phone because that's where you went to high school? Number two, do you still ride your bike to work?
Yes and yes.
Thank you very much, Dan.
Thank you, Alan.